Hello and welcome to our channel. Today we will be discussing organic nomenclature as part of our organic chemistry unit. Specifically, we will review IUPAC naming conventions. For any IUPAC name, there are three components: the prefix, the parent, and the suffix. The suffix indicates the functional group of the molecule. To identify the suffix, you'll need to look for identifying characteristics of the various functional groups. I've listed a few of the basic functional groups and their respective suffixes. For a more in-depth look at identifying functional groups, check out our channel's basic functional group video. For the sake of simplicity, all examples used will be alkanes and have the suffix -ane. The parent is based off of the number of carbons used in the main chain. While a majority of the parents follow standard naming conventions, the numbers 1 through 4 are a bit irregular. To help yourself remember the first 4 parents, use the monkeys eat peeled bananas phrase to recall meth, eth, prop, and bute. However, one must be able to identify the main chain so that they can properly find the parent. There are 3 rules for finding the main chain: maximizing carbons, maximizing side chains, and minimizing the length of the side chain. This is kind of a secondary thing, but if you notice that you have particularly long side chains, that is usually an indicator that you have mistakenly found the main chain. Looking at this example, 2 potential main chains are shown, but the correct one is the one that has 5 carbons because it maximizes the total carbons in the main chain. It also reduces the length of the side chains from 2 2-carbon chains to 2 1-carbon chains. The prefix is based off of the side chains and contains 2 parts: the actual content of the chain and the location of the side chain on the main chain itself. The location is typically a sort of pre-prefix for the overall name. Regarding content, a side chain is either a halogen, some sort of carbon-based chain, or in the case of an OH being present alongside another functional group, a hydroxyl. Below, the prefixes for various situations are listed. If there are multiple of a given chain, di, tri, or tetra is used to indicate that multiplicity. The next portion is the pre-prefix, which is the location. This step relies on properly numbering the main chain. To find which numbering is correct, number the potential configurations and add the numbers of the values of the side chains. Those sums will be compared and the lowest sum is the correct one. If you look at the example below, you will see that there are 2 potential numberings, but when you look at the locations of the side chains, you'll find that the sum of 2 plus 3 is less than the sum of 3 plus 4, and therefore that is the correct orientation. Pause the video now and try a couple of our complex examples. Be careful, as they are intended to deliberately trip you up, and review all of the rules and guidelines we have covered during the video. Here are the solutions. If you look at A, if you number the main chain from the leftmost point, you will only get 8 carbons, which is why this is the correct main chain. And while you can number from the bottom right and still get a side chain total of 10, remember that you prioritize alphabetically. Thus, 4 goes to ethyl instead of methyl. Other common mistakes that might occur for B: if you start the main chain in the middle chain, you will still have 8 carbons, but you only have 4 side chains versus the 5 created with the proper main chain. And that's all I have for today. Thank you for watching. If you have any questions, comment them down below and we'll help you out.